Chapter 1, Section 5, Differentiability and Continuity. So let's begin by defining those two terms. So if something has differentiability, it means that we can find the derivative. If something has continuity, it means there are no gaps. So in earlier chapters, in sections 1.3 and 1.4, we talked about differentiability, meaning being able to take the first derivative of a function at a certain value in terms of that limit. So if a limit exists at x equals a, then the function f of x is differentiable at x equals a. And then if a limit does not exist at x equals a, then the function f of x is not differentiable at that value for a. All right, so now we're going to take these terms and look at them graphically. So the non-differentiability of a function can manifest itself by the graph of f of x if having no tangent line at x equals a, and this happens when a sharp point or a corner is present, or having a vertical tangent line at x equals a. So if we look at the following graphs, then at the first one, this is where we have like what we call a point, okay? It comes to a point on the graph. So it is not differentiable at that point or at the value a, and that's really important to note that we're specifically talking about at this value for a. In the same kind of idea, if you have something like a cusp looking like this, coming again to a point, at the value for a, the function is not differentiable at that value for a. Same thing exists when we have a corner at the value of a, and then if at the value of a we have a vertical tangent line. Again, that exists at the value of a. So something that's important to note is that all of these graphs are continuous, but they are not differentiable at the value of a due to those geometrical occurrences. Okay, so if we look at these other graphs, a function is continuous at x equals a provided that the graph has no breaks or gaps as it passes through the point a, comma, the function of a. Can you identify the reasons why the following graphs are discontinuous, and where does this occur? Well, they're discontinuous because if I were to take my pencil and try to trace them, a gap or a jump will occur. So if I wanted to circle the values where we have discontinuity, it would be right here at 1, right here at 2 for the first graph, and then it would be right here at 2 for my second graph. So these graphs are not continuous. You can also say they have discontinuity. So they're not continuous, which means at those values, again, that sign means therefore, at those values, they are not or the function is not differentiable. So to recap one more time, we can have, if we have a continuous graph, so far it seems like we are good, we are on our way to being able to differentiate. However, if there occurs a point, a cusp, a corner, any of those things on this page, even though it's continuous, but these things are happening, and vertical tangent lines was that last one, if one of those four things are occurring, then it's continuous but not differentiable at that value. And then if it's not continuous, it's not differentiable at all. So the relationship between differentiability and continuity is, this is just the formal way of repeating what I just said. If f of x is differentiable at x equals a, then the function f of x is continuous. So if we can find the derivative, it means it's continuous at that value for x, but the function could be continuous but still not differentiable if it was a corner or a vertical tangent line or a cusp. So it is also important to recap the limit definition of continuity. So when we talk about limits, a function f of x is continuous at x equals a provided that the following limit holds, meaning we can find a limit there. Remember, if we found a limit of a graph like this one right here, we would say it doesn't exist because of that discontinuity. So we're kind of putting all the pieces back together now. All right, so this ends this section of chapter 1.